Hi, in this video, I'll be starting a new series on solving the H2 Mathematics 2019 paper 2. So let's begin. For question 1, we are now given that I equals to the integral of x bracket 1 minus x to the power half dx, and we're supposed to use integration by parts to solve for I. So you keep x and then you integrate this portion, which is just 1 minus x 3 to the power 2 over minus 3 to the power over 2. Then you minus the integral times the differentiate. And the reason why you choose x to be the differentiate is because when you differentiate x, it becomes 1 and it gets removed. So it makes the expression simpler. So when you want to do integration by parts, your focus is to make the expression simpler. And now you can integrate this because it is like the same thing as integrating this term. So this is just 1 minus x to the power 3 over 2, which just become 1 minus x 5 over 2 over negative 5 over 2. Why do you have this negative? Like the same reason why it's negative here, because inside is 1 minus x. When you differentiate it, you also need to differentiate the inside. So when you integrate it, you also need to like take note of what is inside the differentiate. So when you integrate it, you get this expression. And actually in the second part, now they ask you a different way to integrate it using substitution, using u squared equals to 1 minus x. So u squared equals to 1 minus x, then when you differentiate 2u du dx equals to minus 1. So we can now do the integration by substitution. So when we want to integrate this, we know that x is 1 minus u squared. This 1 minus x square root is u, and the dx changes to minus 2u du. And because of that, we are able to integrate it and integrate minus 2u squared plus 2u cubed, which results in this. And then you must substitute back the u as 1 minus x to the power half, which is 1 minus x power 3 over 2, and the other side is 1 minus x 5 over 2. And we say that these two expressions actually looks kind of different. Here's like x 1 minus x 3 over 2, here's just 1 minus x 3 over 2. And so, but we are actually now to show that they only differ by a constant, which is this c1 minus c. So we just take this expression minus this, and we actually see that we can do some simplification to help us reduce the equation, and actually results in us only having a constant left. And I'll leave you to it to see through this method. It's just algebraic manipulation. For question 2, now we are supposed to sketch the graph of 2 minus x over 3x squared plus 5x minus 8. So you just plug into your GC and do it, but for the asymptotes, you gotta find them. And of course, one of the asymptotes is y equals to 0, since this is a proper fraction already and there's no constant term here, or oblique asymptotes. As for the bottom, this part will form one asymptote and this part will form another. So x equals to minus a over 3 and x equals to 1 is another asymptote. You can use the GC to find the minimum points, maximum points, and the intersection points, or you can sub them in normally. But since the question never state for any exact values, you just use your GC and it's fine. So you just see how the graph looks like on the GC and you just draw it accordingly. And now we're supposed to solve the inequality for when this graph is above 0. So when it's above 0, it's on this side of the graph and this side. So for this side, that means x is less than minus a over 3, and for here is 1 to 2. And hence we're going to solve it now for when this equation is greater than 0. So we see that this graph is minus 2 minus x, but here is x minus 2, so we need to make it 2 minus x, so we need to times minus 1 throughout. But when you times minus 1 on the other side, you need to flip the inequality. So we want the part where this graph is now less than 0. And this part is more than 0, earlier we found. So to be less than is the complement of this set of solutions. So the complement will just be minus a over 3 to 1, and x is larger than 2. Or you can just see where the graph is negative, which is here and here. So this should be a fairly straightforward question, and most of the the solution, it can be just found using your GC for the first part, and the second part is just referring to the graph to solve it. For the third question, a solid cylinder now has a radius of R and a height of H and the total surface area of 900, and we're supposed to find the max volume. So this is a differential application of differentiation question, and to find the max volume, we first need to use the total surface area to express H in terms of R, which is what the normal step would be. So you just use the total surface area formula, which is 2 pi r squared, because there's two circles. And then you want to find this curved surface area, which is 2 pi r h. This will result in H being 900 minus 2 pi r squared over 2 pi r. Then the volume is just pi r squared h. And so now we substitute the h for this r formula in terms of r. And we actually get that the volume reduces to 450 r minus pi r cubed. To find the maximum, we need to differentiate it. So we get this expression. And dv dr equals to 0. Because you want to find maximum point. Then r has to be square root 150 over pi. And we have to reject negative since r is larger than 0. Then we use the second derivative test to test whether this is indeed the maximum, and it is so, because when you sub in the r here into the second derivative expression, it is negative. And because of that, we know that at this point r, v is maximum. So the maximum v, you just need to sub this r value to get 1500 times square root 6 over pi. And that would be the maximum volume. And now we're supposed to find the ratio of R over H that gives this maximum volume. So that gives this maximum means R has to be this. And we just need to sub this R into this H expression and take the ratio, and we see that it's half. So at this point, if you have any question, please feel free to leave it in the comment section and I will answer them. Moving on. For question 4, we are now given that fx equals to secant 2x, and we are supposed to find the first and second derivative. So to find the first, you just differentiate secant 2x, which is just secant 2x tangent 2x. Then you need to differentiate the inside, which is 2. So it's 2 secant 2x tangent 2x. For the second derivative, we just use the power rule. Now we differentiate tangent first, so it becomes secant squared 2x times 2. Then we differentiate secant 2x later, which is 2 secant 2x tangent 2x. And we can reduce this expression to 4 secant 2x times 2 secant squared 2x minus 1. Hence, when x is 0, we know that f0 is 1. The first derivative evaluated at 0 is 0. And the second derivative evaluated at 0 is 4. So, fx is 1 plus 0 times x plus 4 over 2 factorial times x squared all the way. And because we only need the terms up to x squared, we can reduce it to 1 plus 2x. So, for the second part, we are now able we have to use the series now to approximate this integral. And so that means when we integrate this, we can integrate, we know that sin secant 2x is close to this function. So we substitute that in and we integrate this power series now, which is easier. So when we integrate it, it's just x plus 2x cubed over 3. And then you just sub in the values and evaluate it. So you get 0.02220015 dp. And for the next part, we're supposed to use the calculator to find the actual integral, the real value, the exact value. And so when we use the GC, we get that it's 0.020015 dp as well. For part 4, now we have to compare the answer. So we see that actually the integrals are similar and same up to exactly the same up to 5 dp. And so the accuracy of the approximation is very good. And the reason for that is because the x value is small. So when it's small and it's close to 0, this approximation becomes an accurate one. And for the last part, they're just explaining why now the macaroon series cannot be found. You say that it's just a 1 mark question, so it is really a giveaway. And the reason for that is because when you see cosecant 2x, it is 1 over sine 2x. So actually it's not defined near x equals to 0. This prevents us from finding the macaroon series, because when we find the macaroon series, we need to find sub f0. But you can't do that because f0 is not defined. So that's all for this video. I hope you have enjoyed it. Please like, share and subscribe. Boost the algorithm, and I'll catch you in the next one. Bye!